Hi, this is Gilles, the radio prepper. I look like a mad scientist today, but I'm not a scientist, so what does that leave? Well, anyways, the QRP-Labs QDX, yes, I got the kit. I've been waiting for this for a long time. Finally, it showed up and I built it this weekend. So I'm going to show you that process. It's a digital transceiver, so digital modes only. You remember a while ago I built one with using crystals, a DSB transceiver, also digital, and it worked, but not so great. I haven't used it since, so if that says anything. But this one, guys, is going to be awesome. And I've known about this for a while, I mean a long time. Actually, since I built that first one, and Hans Summers at QRP-Labs told me, hey, I have something else in the works. Told me all about it, but I was sworn to secrecy, so I couldn't say anything. But finally, it's here. So it's done. I'm going to show that to you. It's a 4-band transceiver, so 20, 30, 40 and 80 meters, and I'm really glad Hans included 80 meters because for NVIS, for prepping regional communications, there is nothing better than 80 meters. So you have actually 4 bands, and it's a really small transceiver. Look at this. There is no tuning involved. The only things you have are a USB port because it has an integrated digital sound card, digital encoder, the power and the antenna, and that's it, nothing else. You have an LED in the front, nice little box, very small, it's very light, and actually I really should build a second one. Yeah, it's awesome. It doesn't even use USB for modulation, so if you want to know how Hans did it, download the manual. I'll put a link in the description below, along with the link to the kit. It's only $60, which is awesome also. $20 for the box, so $80 you get a super awesome digital transceiver. And nobody else does that. And this covers the whole bands, not just a little fraction, not just one frequency. So you can use it for FT8, JS8, which is what I'm going to use, or Whisper, or all those modes, and it's it's just incredible. I told Hans that what he was doing went beyond business, and what I mean by that is that these little radios, and he has sold many thousands of the QCX Morse code transceiver. And this one, I'm sure, will be as successful, if not more. That's what Hans really truly believes. And it's important. I think his work is very important for us because, like I said, this radio might be necessary in a way someday. And that's why I truly believe that what he does is very important. For some reason, it's just a kind of an intuition, so to speak. And so Hans, thank you very much for making all those kits for us, because I think it's important. I've never been a fan really of digital modes for prepping, but they are so efficient. Like JS8 can decode signals that are 24 decibels below noise level, which is absolutely incredible. Even CW, using Morse code isn't that efficient. It pains me to say that because it's my favorite mode. Although it does bring a little bit more complexity to your setup. Now, with transceivers like this one, you reduce the number of cables and you just have a tiny box that's plugged in your computer, and that's it. So it does definitely become a more attractive solution and a more practical solution. And that's the reason why I think it would be stupid to ignore digital modes just because you add a computer. Now, of course, I don't think it should be your first option, but definitely something to have. and this kit is really the best one so far, and I think it will cover all my needs for digital mode. You know, because I use JS8 and that's it, and that's a good excuse to learn more about it also and read the whole manual, which I still haven't done. So, but definitely I will include digital modes now more often in my you know, setups and when I go to the field and experiment, because it's just that good. You know, you just can't ignore them. It's too efficient. You'll make contact with those 4 bands. You'll make contact pretty much almost guaranteed every time with someone. And it's a mode like JS8 is a mode that is getting more and more known, and people are starting to really to use it now, and you always find someone on the air using JS8. So as time goes, digital transceivers will get, you know, smaller, and I mean, it doesn't get much smaller than this one, but maybe integrated solutions with the computer, or, you know, Raspberry Pi or anything like that with a built-in screen. I saw something also called the something deck, cyber deck, I think, yeah, which is like a Pelican case with a, you know, keyboard, like typewriter type keyboard, a screen, the Raspberry Pi, and you know, whatever else you want to add to it, and that's pretty cool. The Raspberry Pi isn't very reliable. Well, the SD cards that the Raspberry Pi use aren't really reliable. So maybe something like a mini PC, you know, 12-volt mini PC would be a better option. Or, you know, a cheap laptop. You know, you get everything in it. You have the computer, you have the screen, you don't have to worry about assembling anything or, you know, anything like that. You get a small laptop, Windows laptop, unfortunately, because some programs only run on Windows, like for instance, the one for WinLink, I think WinLink Express, something like that. So unfortunately, it's better to use Windows in that case. You know, cheap laptop, cheap Windows laptop, 12-volt power supply, and you're good to go. Add the QDX, bingo, you have a simple solution. You can put that in a case. It adds stuff to carry around, but you can make a small package still, so it's becoming more attractive. Let's just put it like this. If you want to see some really cool setups for digital modes, go to Julian's channel, OH8STN, that's Survival Tech Node, and he does an awesome job with JS8 and Raspberry Pis and all that stuff. So I highly suggest that you check his channel and subscribe also. Here are the contents of the kit. The case is very small, as you can see here, compared to my hand. It's really tiny. It's a small radio. The circuit board has all the SMT components already soldered on, so that's great. There aren't that many components actually, if you can see the bag here. It's just very few because you only have the through-hole components to worry about, and of course the toroids as well. So I'll get going and just stop on the particulars of this kit. Now the manual is absolutely awesome. Hans makes very good manuals, and there are absolutely no reasons why you wouldn't be able to build this kit. Before you start the build, you need to decide if you are going to run this radio at 12 volts or 9 volts. In both cases, output power is going to be 5 watts. I decided to go with 12 volts because, of course, most of my radios run on 12 volts. I have lots of battery packs on 12 volts, and it allows you to use a car battery. You can run this radio down to about 6, maybe even 5 volts. Now, if you wired it for 12 volts, at 6 volts, you'll get 1 watt. If you wired it for 9 volts, at 6 volts, you'll get a little more than 2 watts. So there might be a benefit to wire it for 9 volts, but it's just a little bit less practical. Although your 2S battery pack, like 2 18650 cells, would work pretty well. I'll tell you, my vision hasn't improved these last few years, and when I said there shouldn't be any reason why you wouldn't be able to build this kit, well, those soldering pads are pretty small, but that's why we have glasses, right? All the ceramic capacitors are now on the board, so I'm moving on to the 6 diodes and the output transistors. I actually suggest that you put in those diodes first so you can reverse the board like this on your desk and solder on the other side. This is not specified in a manual, but I'm going to use a bit of heat conductive grease here. It's probably not necessary, but it can't hurt. And don't touch that stuff with your fingers, by the way, it's carcinogen, so pretty nice. You have to solder the Tcxo module, and you have to be quick on this one because the pads are a little fragile, so be careful soldering it. Okay, this I need to show, and it's the building of T1, which is a transformer. We have this core here. It's going to be 3 turns primary and 2 turns secondary in my case, because I want to power the radio with 12 volts. So I'll start by letting a bit of wire here on the end. Put it in here. So the primary, the 3 turns, has a center tap, and you'll see how that works. So I thread the wire in. So that's 1 turn. Every time it goes through both holes, it's 1 turn. 1.5. That's when we are going to make our tap here. So that's 2 turns. And I'm going to leave the tap here, so that's going to be just like so, and I'll leave it like that. And now I finish my last turn. Well, so that was 1.5, 2. Now that's 2.5 and 3 turns. And you can see the turns here. You have 1, 2, and 3. And the wires will come out this way. So here is our primary with the tap. Now I just have to wind 2 turns on the other side, and the wires are going to be coming out this way. Of course, I, like a dummy, I didn't read the manual, and I cut my wire in half, and that's bad because it should have been used, the leftover should have been used for L14, and I didn't read it, and now I'm screwed. Well, not exactly, I have spare wire, so. Okay, so on this side, half turn, that's 1 turn. Alright, so half a turn. That's it. So this is my secondary, 2 turns for 12 volts, center tap for the primary, and here's the primary. And that's it. Alright, so that's probably 50% of the kit right there. Now, a good piece of advice about the manual, guys, always read a page ahead of what you're actually doing, which I didn't do, and it's gonna save you a lot of grief. Alright, as much as I would like to finish this tonight, I'm pretty tired, and I don't have to. I can finish that tomorrow night or, Sunday morning, because, well, I do want to test it Sunday afternoon, so, and make the video for you guys. So, fortunately, you don't have to wait. L12 is a multi-tap inductor, so there are 3 taps. I'm going to start my first turn here. That's already 1 turn, and I'm going to 19 turns. That's where the first tap is located. So that's 1 turn, second turn. You always count the turns on the inside of the toroid, so that's 2 turns. I'm going to add a third one, 3, and I'll go up to 19. So I have 19 turns here, and on the 20th turn, so here it is, I'm going to just leave a little loop there. I'm just not going to tighten it all the way. And usually I would twist them together, but it doesn't say to do that in the manual, so I'm just going to leave them like that. So and now I'm going up to 30. So here's where I started. 19 turns, 1 tap, 30 turns, 1 tap, 36 turns, another tap, and a total of 41 turns. The manual says to use your soldering iron and just wait 10 seconds for the enamel to burn, so to remove the insulation. But I like to use my pliers. Now that's it's very dangerous because it's easy, very easy to break that wire. And really I shouldn't be doing this, but that's the way I've always done it. And I'm very careful because I broke a few, so we'll see how that goes. The difficult part here, of course, is insertion, and that's not going to be very easy with all these wires. I managed not to cut any wires, so that's good, but I'm gonna have to do this off camera because it's just a mess. Yeah, that won't be easy. Alright, I did it. Now I just have to solder it on the other side. So all my toroids are now installed, nothing special about that, very easy to do. The last hurdle is to build this little Trifilar Transformer. You'll notice here that the wires are twisted together. There are 3 wires, so 3 come out on one side and 3 on the other side. You will need a multimeter because you need to check which is what. Those wires you have to identify so that they can go in the right holes on the circuit board. I'm not going to show you that. It's very well explained in the manual, and I highly suggest that you download the manual. Alright, this one gave me some trouble, guys. The manual says to wait 10 seconds while soldering to burn the enamel off the wire, but I don't think 10 seconds is going to be enough in all cases, so you might have to wait a bit longer, so make sure you test it very thoroughly. The only thing that bugs me about this kit is that you have to remove 4 little inductors here on the board and replace them with this type of inductors, and that means unsoldering those tiny components. It's not that difficult, but it's just, you know, an extra step. Probably the problem surfaced after the boards were already made, and that's why you have to do it yourself. Now, this type of correction is pretty common in kits, you know, because sometimes problems don't arise right away. Still, it's just a pain. But hey, let's do it. That's the last step. Everything else is on the board, including the connectors, the LED, so let's do it. The trick to unsolder these surface-mounted components is to try to heat them on both sides at the same time. Of course, if you have a flat tip soldering iron, that's much easier, but I don't, and so I'm just pushing it on the side a bit while heating it up, and at some point it should give. There we go. Not as hard as I thought. You know what, this correction is really frustrating, not easy at all, because you have to solder on surface mounted components, and that is just not easy to do, so very time consuming. And that's too bad because otherwise this kit is fairly easy to build. Okay, one side. Oof. Well, I hope it was worth the effort. It's pretty ugly, but you know what, once it's in the box, it won't matter. It certainly looks good in the box, and the great thing about this radio is that there is absolutely no tuning required, so once you've done building it, it's good to go. Alright, so let's go to the WSJT suite of program, and I can see QDX transceiver, so awesome. Audio input and output. Now I'm going to select the rig, which should be a Kenwood TS440. Well, there is no 440, it's 440S, so I'm going to choose the TS480, and that should work as well. Now the cat control, so that's what's going to control the radio, and yeah, I'm not sure that's the right one, so yeah, here's the good one after I restarted the application, and cat control. And now I'm going to ignore that, and I'll test the PTT button, test cat, and it's okay. So let's move on. Well, if I test the PTT, it seems to work, but the wattmeter isn't moving one bit, and that's really concerning. It's really not transmitting, so disappointing. Well, I must have messed up somewhere. Troubleshooting now. I hate troubleshooting. Well, you must be as disappointed as I am, but I will fix that radio. And you may wonder, why did I publish this video since it didn't work? Well, it was the build video, so this video was concentrating on the building, not really the testing. That will be for part 2. Also, I wanted to show that, sometimes things don't work as planned, and it's just the way it is, and I would say it's normal. It does happen, and then you troubleshoot your kit, and if possible, you fix it. So actually, Hans just emailed me back just now and suggesting that maybe it could be a software issue, that I haven't set up the software correctly, which is possible, so I'll check on that. That will be for part 2, because I don't have any more time now. But I'll definitely check that, and I'll check the hardware, and I'll redo the soldering on especially on the transformers, and see if that does it. But I'm really hoping it's the software. There will be a part 2, definitely, and I will fix it, because I really want this radio. Have a good one.